Hello everyone. This meeting of our research group is going to be in English. This meeting is going to be shared with public on our YouTube channel. So if you feel okay, your interaction, your discussion will be shared public. Otherwise, feel free to reach me before sharing this video tonight or tomorrow at most. Now, I will start introducing the SHACPE pipeline for you. At first, SHACPE stands for Scientific Hypothesis Autonomous Causal Pathway Engine. Uh, mhm, admit. We are partially AI powered. We okay. Uh, we are making a tool to enable researchers to make causal inferences from published literature uh, with great potentials, and we are opening the door for new kind of research and using the ability between our hands, the power of this tool. We also accelerating. We have a goal to accelerate research and scientific discovery. Uh, Also, we are building knowledge graphs for scientific research. Systematic review are overwhelming. Systematic review can take a lot of time, and part of the SHACPE pipeline is to automate the process with caution and with quality assessment at every step of this application. Some of the features in the SHACPE pipeline right now: smart search. We have an AI assistant that helps you to formulate your research protocol and research query for PubMed. Also, we have an AI screener that's built on GPT, ChatGPT model, and Gemini, and you can also use whatever model you want in the pipeline. But this model was tested initially in ChatGPT and Gemini baseline models. We are using. We are using some of the models that can, some of the basic models, is the small models. Also, in the future, we have current research to test and to train our AI from built on some open source models. But this is for the future. Currently, right now, we are very satisfied with the results. In the future, when we scale up, we definitely going to have our specialized models, our own models running on our own servers. Also, some of the features is the best way extraction. This is very interesting and great feature. Network, we are doing network analysis. We are doing directed acyclic graphs for causal inferences analysis. This is one of the most important features. Also, there is a scientific illustrator which generate which generate uh, very nice visualizations, as you have seen on our research group. This is the web line. You did PubMed search, AR screening, relation extraction, and in the step and analysis and processing. This is a step where most of the computation takes run. And finally, we build the graphs and visualization. Uh, for the data cycle graph analysis, we automate node classification. We find the exposure, find the exposure, and normalize the exposures, because this evidence comes from different places, and there is variety of naming and in medical literature for the same exposure. Also, we do the same for the outcome, for the confounders, for the mediators, for the colliders. We construct a complete map, causal map, even if it comes from different literature. Using our pipeline, we can make a complete map, as you are going to see in seconds with me in the demo. Uh, the application, as you're going to see, is very interactive. There's a lot of features, a lot of interactivity inside every feature. We are trying to make, as in the past, if you have followed my previous presentation to our research group about the agentic flask framework. This application is really built on a very idea. It's very similar, an idea very similar to what's going on in the agent flask. The agentic flask framework for building applications some way is embedded inside the code of this application, and is going to take place in the future, and going to be more and more embedded inside the application. We still have a lot of ideas to add to this application as we go on. Multi-provider AM support, yes, and also we use unsupervised models, and we use our own machine learning models that can be trained during the run and can give you nice results. Okay, let's now go to the pipeline. First, you need to sign in the application. Make an account, then you need to sign in. Admin. Is there any questions? Yes, for the development.
Yes.
Is great, promising. The video will place a medical research work on. No. It is very different idea from what we are doing in systematic review and meta analysis. It's different. It makes your work easier and gives you new abilities and the new uh, a new view of the world. Okay, now let's switch the project. Let's refresh. Now let's start by making a research question. Can you suggest me a research question? For example, maybe we want or I want
دكتور
to.
احمد
Okay. مين
يو
اتفضل دكتور.
share
اتفضل.
screen. There is no share screen I feel.
Okay. I'll share my screen. Thank you for reminding me. Okay. Now uh, I'm using this AI feature. I'm telling my models that I want to understand the maybe name a drug. For example, a drug for Alzheimer's disease. Okay, let's Alzheimer medication. Let's make the question more obvious. Okay. This is the queer Alzheimer disease, drug therapy or medication or pharmaceutical treatment or drug treatment. Okay, this is good. Okay, this is an open question, and we like here open questions that can gather as much as data as we can about the topic to make a complete deep map on different levels. As we discussed before in on the group, the research question for SHACPE pipeline, the hypothesis specifically for the hypothesis synthesis pipeline and causal inferences, it is best works with questions on at least two levels, molecular and cellular level, or cellular and anatomical level. And more the levels you add to your research question, the more depth you add, the best or the better the results you get. Okay, now we have this research question. What is the types, efficacy, and safety profiles of medication used to treat Alzheimer's disease? Study involving human patient diagnosis and studies focus on pharmacological treatment for medication of Alzheimer's disease, randomized control trial, article published in English, exclusion animal in vitro studies focus on not focus on Alzheimer, case reports non-English. Okay, and this is our search term. Let's make the model. Let's make the search. Catch the first 20 paper, 20 relevant paper. Now we add all of them to the library and click on deep screen with AI. Proceed. It will take some time to finish. As you can see now we have started screening. One very useful feature, but we are not going to use in this demo. It is the automation feature. When you click on the feature of automation and activate the automated mode and click start, it will do the screening, extraction, clustering, and eventually it will give you a final graph. You have here different tools for monitoring your pipeline. Also, we have another very nice automation tool inside the analysis that we are going to demonstrate in a few seconds or few minutes. Okay, now we have 14 studies excluded, only one included, pending 5, still doing its work. Okay, 19 study were excluded, only one study included. We active comment on particles, Alzheimer's disease, compounds. Okay, manually, I will add some random 2 more studies to make the model work better. For example, let's add this and add this and add this. Okay, we have 4 studies, and Now you understand how the AI screening works. Okay, you can now also you can also upload instead of doing search from PubMed. You can upload your abstract in this format, in a CSV file format, with these columns and the exact namings. They should be the exact naming ID of the paper. ID is should be the PubMed ID or DOI of the paper, or link of the paper, title of the paper, abstract, journal name, and year of publication. After that, you can do further full text screening. You can upload the full text from here, and our pipeline going to give you this option. This option going to be activated. Screen full text. It will screen the full text for you, and it will do more steps of screening like this. Here in the Prisma flow chart, we have identified 20 papers, abstract screening 20 papers, excluded 16 papers for text, so 4 papers, but we didn't assess the full text, so we didn't exclude everything this step. We will continue to the next step. Also, you have here quality assessment for the paper, but quality assessment you need to upload the full text paper. Quality assessment for now it is under development and under testing. This feature is under testing. We are not going to release it very soon. It will need a lot of work and research. Until that, you can enjoy other steps and manually do the quality assessment. Quality assessment is necessarily necessary in papers with few. When you are working with few papers, working with RCTs, maybe working with drug efficacy on clinical trials, on or human studies, but it is not necessary for papers in which you are making a comprehensive narrative review, or you are making a complete hypothesis of some mechanism. Anyway, you feel free when the application is online. Feel free to test it. Okay, now after finishing the screening, we go to the extraction, and let's start extraction. It will take some time. We'll do the extraction, and after that, we will see that start processing will be activated. We will click start processing. In meantime, okay, it started to do the extraction. For example, memantine optimizes cognitive function, cholinesterase inhibitor optimizes cognitive function, etc., etc. Also, in here, it explains what is going inside this. Do you have any question till now? Okay, Dr. Hussam, you are raising your hand. Please feel free to ask your question.
I'm sorry for that. I wanted to say that to share the screen previously, but I did not. I forgot to load down.
Okay, no problem. So now we have finished the extraction. Let's start the processing. This is where the most important part of the application, and this is where the real magic happening. For the embeddings, we use we use a model to make embedding representation for this extracted data. After that, we cluster them and supervise with unsupervised models. Finally, we do a final quality check and optimization for the extracted pathways to make sure that everything is ready for the next analysis steps. It will take some time. Okay, we completed this step successfully. Now let's go to the graph. Let's see. We have now we have two clusters. First cluster, it's antipsychotic agitation reduction. And in the second cluster, it is related to neuroinflammation and cognition. Let's start rendering and see what is inside each of them. Let's make this. Okay. For example, let's focus on risperidone, for example. Risperidone in here, it is antipsychotic agitation reduction from the antipsychotic agitation cluster. A cluster name antipsychotic agitation cluster. Okay, this is the color of the cluster, and this is the reference. And you can open the reference in here: sequential drug treatment algorithm for agitation and aggression in Alzheimer and mixed dementia. You can see in here there is okay. After baseline assessment and discontinuation of potential exacerbating medication, sequential trials are recommended with risperidone. Okay, so risperidone is one of the drugs that already have been mentioned here. So you can, whenever you suspect or there's an error, or you want to know, you are interested, or you are interested in some nodes, or to know more information about this node, you can click on the node, see everything related to the node, the network context of the node, also the network analysis. This is the entire network analysis, including all the clusters. You can see in here agitation is taking the leadership in the degree metric between this the neuroinflammation, closeness, amyloid beta aggregation, and eigenvalue. It is risperidone. You can also do individual cluster analysis, and you will see all of this things. In here, agitation is taking the leader of centrality. Agitation is taking the leader of centrality, as you can see, because it has the most connections to other things in this cluster. You can also check the other cluster, neuroinflammation cluster, and neuroinflammation is taking the leadership. Okay. Now you can also click on one cluster, or click on one cluster, choose one cluster to edit. Also, you can click on a node, edit a node, or delete a node. You can also, from this part, you can click add a node, even if you see that your analysis have missed some important nodes. You can manually add them from here. You can also create a connection between two nodes, and okay. Also, you have different visualization. You have the ability to do different visualization. like this. This is hierarchical visualization. This is a grid visualization. This is a circle visualization, and this is concentric visualization. This is the best one of all. For the analysis, uh, you can simply check one node. Okay, you have these different nodes. You can click on one cluster, or different or all of the all clusters. For example, let's start by neural information and generate summary for this cluster, and it will summarize everything, all the evidence from this cluster. It will take some time. Okay, now our summary is ready. You can download, export this in plain text or in Markdown format. You can read in here: Alzheimer disease neuroinflammation and cognition pathway represents a care signaling cascade involving 38 molecules components. This pathway elucidates the complexity, etc., etc. Now it will start. It will start integrating everything in the evidence with reference. It will not miss any reference or any papers that you have cited or you have used in the extraction of these pathways. It will also integrate evidence from different papers and make a final comprehensive map. Now, I will prepare a plan for the AI to start creating an illustration, a nice illustration for this cluster. You can download, for example. Let's download this, and let's wait for a few more seconds. It takes some time. Okay, now the plan is ready. This is our plan. You can revise your plan before starting to implement it in the a graph. I what I like to do is to create the graph first and visualize what is going on to make better understanding of what is really happening, and then I can go back and edit anything that I don't like in here and generate again, and finally I will have uh, a nice final output. Also, you can download the graph that you have generated in here and go to the scientific editor. And you have here Sci Illustrator editor. Using the Sci Illustrator editor, you can edit your graph to make it match your expectation. Now let's prepare for the DAG or directed acyclic diagram of evaluation. Okay. Let's prepare our research question. For example, let's take the risperidone. Let's search for risperidone. For now, if we search for risperidone, it can be found only in this cluster. We can choose this cluster, and okay. Now let's download this, and we will go back to visualize it while we are doing the ZDAG visualization. What is and let's search our what is risperidone effect, how or how it is effective in treating treating uh, okay, sequence trial. Inherent sequential Alzheimer and mixed dementia, treating aggression, agitation, and aggression in Alzheimer and mixed dementia. Okay, the exposure, our exposure is risperidone, and the outcome is agitation and aggression. Okay, let's now click evaluate, and it will do the evaluation. Let's revise the graph we have generated in here. Alzheimer disease neuroinflammation and cognition pathway, nanomaterial therapeutics, and the nanomaterial therapeutics. This is the pathological cascade. We have in here amyloid beta and M1 microglial activation. Actually, amyloid beta and microglial activation, two important and common pathways for a common series that explain the disease nature or the pathophysiology of Alzheimer. Because also we have included only two papers, you can see that we have only M1 microglial activation and amyloid beta, and it's not detailed, but it is good enough to start. To start with, here we have also microglial polarization dynamics. We have this in here. We have also tau pathology and mitochondrial dysfunction. Okay, nanomaterial delivery and therapeutic outcome. Okay, finally therapeutic outcome and neuroinflammation and cognition function. I will share this graphs and the text with you so you can revise on the group and share your ideas. But anyways, as you can see, this is only for demonstration purposes. We are not expecting a lot of things to from this run. It's very simple, only two papers. Okay. Now, let's see the causal DAG visualization results. As you can see in here, there is a risperidone, okay, risperidone effect. It has moderate effect and moderate effect on agitation and aggregation. Also, it is mentioning, it's for now, the exposure is in blue and outcome is in green. And if there is a confounder, it will be in this color, and the mediator is on orange, and unmeasured variables, if existed or mentioned or criticized by literature, it will be presented in here with red. But for now, let's make the legend go away. And we have different treatments in here. These different treatments have been mentioned in the two papers. This is the one of interest, and we have in here our question, our research question: how is risperidone effective in treating agitation and aggregation, Alzheimer, and mixed dementia? Exposure is risperidone, and outcome is agitation. This is 10 node. There is 10 nodes and 16 edges for the evaluation. The quality of DAG is fair. It's not strong, not moderate, but it's fair, good enough. Okay. The causal effect is identifiable. There is a direct causal effect between risperidone and agitation and aggregation outcome, and confidence is moderate. Risperidone shows direct causal effect on agitation and aggregation with no confounders detected. However, data lack confounder and the mediator information, limiting causal inferences confidence. So we need to include more literature to identify the real and a complete causal pathway from complete causal pathway. Anyway, now we have recommendations. Adjustment state, I would, if there is backdoor criterion, it will be found in here. Recommendations, optimal adjustment strategy, no co-founder, etc., etc. Also the best analysis, and finally it gives you this Dagity code, so you can export also, or you can use in Dagity in here. Copy, let's copy, and okay, and let's paste our code, update. Yeah, it will give you the same diagram like this. This one that we have generated for you. If there's any inconsistency between the naming or between the naming, sometimes the model make mistakes, and sometimes it can represent risperidone drug with two names, or into two or three or more nodes. So we can run the normalizer and the integrator, integrate the normalize and the integrate function. This can make sure that your causal diagram is formatted in a good way. Now we okay. Uh, we summarize only one cluster, but can we summarize the entire evidence from different clusters? Actually, yes, we can. We can summarize all. If you have three clusters, five clusters, 10 clusters, even 100 clusters, you can select all of them and summarize all of them and build an entire big map about the thing you are studying. Also, you can still make summary and make image library, especially when you have a lot of clusters, like more than 10 clusters, and you want to run everything automated. We have this automated tool like we had in the first few steps with the automation function that can help you to do all the pre-processing. Now we have also an automation to make everything here automated for you. I'm clicking now generate image, and everything is fine. And now start the processing. It will take 1 minute or 2 minutes to build our library. Dr. Hatton, do you have questions?
Of course. Dr. Ahmed, how are you?
Alhamdulillah.
Firstly, I'm so impressed with your work. Literally, you are doing something great and something different. And really, it's impressive, even if it's the beginning. But as a researcher and as a physician, how can I use your tool? يعني, what's will the benefits I will get when I using your tool, and the difference when regular literature search. I got it. It's like automated the literature search.
Okay. I understand your question. Yeah, it's not a simple automation for systematic review or for meta-analysis or for data extraction. It is beyond that. We are in here trying to make, for example, I will give you an example. There is a professor of hematology who reached my colleague and asked him a question about something that's very serious, and there is no effective drug until now to treat this condition, and there is an ongoing research in the area to identify potential biomarkers and potential targets treatment targets and diagnostic targets. And there's a lot of research. I mean, there's a lot of basic research, but no clinical, no enough clinical research, or clinical research on real patient. Okay, we tested this pipeline on this idea. We searched the entire corpus of literature. We identified 1,001 and 180 papers. We constructed a network of 7,000, more than 7,000 nodes, and it is consistent of different molecules, cellular mechanism, anatomical, also on the anatomical level and on the clinical and behavioral level, and even on the functional level, and that is also on the psychological level of the patients. It captured everything about the disease and the complications, and starting from the molecular mechanism, cellular interactions, going to anatomical level, everything, literally everything. Finally, we constructed an entire map of the disease, and we made a very big library of underlying mechanisms on different levels, and we integrated everything. This work now is going under revision. We are revising the now we are revising the results, and we are trying to understand and absorb all of the information that we have created. But everything seems like interconnected and amazing. Okay, and in this example, I'm telling you, we are using the tool in a very different way. Okay, in a very different way. This can be, you can see this in the level of narrative review and systematic review, but you will never find this level of comprehensiveness and comprehensiveness, and also integration between. We can integrate many different things on different levels automatically. Our brain actually cannot do this, or cannot understand all of this without using AI, or without using deep learning models and machine learning models. With the help of this tool, I think we are going finally to be able to make the bridge between basic science and clinical science, and maybe we will help research in the future to understand things and build better series and pathological pathways, connecting molecular, cellular, and anatomical to the functional and clinical outcomes in a better way.
So if I got you, it's connect the previous unconnected, like islands, unconnected literature.
Exactly.
I got it from the clusters. Clusters was the image and the nodes. It's very impressive, but I think it's a little bit complex. So how can I get like a direct, straight information from these clusters?
Yes. Okay. For example, now I'm clicking on my clusters. Okay, and using the AI pathway integrator, and it will make an integrated pathway, final integrated pathway from all of the clusters, and it will build a final comprehensive map, including everything related to the pathophysiology and mechanism and everything. Okay, This is the integration. This is integrated analysis synthesis two major therapeutic and pathological domains of Alzheimer. The complex neuroinflammation and cognition decline pathway, including novel nanomedicine. Okay, you remember the node? The second node, it was about nanomedicine and neuroinflammation. The first node was about risperidone, I think, and other drugs. In first cluster neuroinflammation cognition pathway, and if we download this and run it, I will open it in another editor. But also you can use the integration in a better way. From this, we can select many clusters together, summarize. It will summarize a more interconnected a comprehensive and interconnected pathway. It didn't save the other one. Yeah, it's about to finish. When you are adding more clusters, it will take more time. Now we have let's explore this. This is a deterministic pathway summary report, Alzheimer disease, pathogenesis, and therapeutic interventions. Alzheimer disease pathology and therapeutic interventions, pathways represent essential signaling cascade involving 60. Now we have 60 molecules or 60 molecular components. This pathway regulates neuroinflammation, amyloid beta pathology, behavioral symptoms through coordinated interaction between black phosphorus, methylene, blue composite, etc., etc. And this is the abstract. Now, this is the network overview. Total unique entities 16, total relationships 53, major pathway clusters. This is the two clusters that we have established pharmacological treatment for AD, microglial polarization and amyloid pathology, tau pathology, advanced nanotechnology, antipsychotic agitation. This is the major things that have been mentioned in these two clusters. This is the complete pathway analysis. In here, it will start from the very basic level and from the initiator going to higher and higher levels until finally it reach the level of clinical. Yes, the level of clinical and behavioral research implications. Everything in here, every information in here, it will come with its original reference. So you can make sure that everything in here is correct and everything is to the point, and the model is not, and the analysis in here is not misunderstanding the relationship or giving you false information. Also, for the sake of comprehensiveness, you have here 16 entities. We have included this checklist, so you make sure that you have on the table. If you render this in Markdown, it will print nice table for you. So we can make sure that everything in here have been integrated in the original text, and you can use the text and relationships that have been integrated in the text to make your manuscript, rephrase them in your way, and use them in your text. Okay. Now we can make a plan from all of this to make a nice illustrator or nice illustration. Also, let's ask our question again, but from all the clusters. It will take more time, but it will give us better results. Okay, now the plan is ready. No, it will take more. It will take a lot of time here. Now generate the illustration. You can also still export this new output. Uh, let's keep this running in the background and go to the thing, I think, the feature in the app that many of you have been reaching and asking about. It is the scientific illustrator and its abilities. Hmm. Okay. For now, okay, it will not open until the processing in here finish. Okay, now, do you have any questions? Go and ask your question, Dr. Hassan.
First, good job, Dr. Ahmad. We really appreciate that hard work. And I would like to ask you a question that I did not get the point honestly very clear about the screening part. You know that the screening part is composed of two parts, the primary and secondary.
Yes.
Title and abstract, then the full text. This level of screening focused, I did not get the point clearly if it's focused only on full text screening or even primary screening. If the primary screening is also applicable, for example, let's consider that there's 1,000 article
Okay.
about the search strategy. How can we determine it and tell it that there's 1,000 article and we want you to do a primary screening for them, which is included, excluded, and so on?
Okay, okay. First, you need to identify your research question in a good way. I use the AI assistant here because the AI assistant understands the system very well and can make can convey my ideas to the model or to the screener, the AI screener, very well. So you can also still write your research question here and make adjustment on it, or or add more details so that the screener can understand very well what are you looking for in the literature. Okay, including inclusion criteria and exclusion criteria. So if the screener see any of the exclusion criteria or inclusion criteria, it will apply them to the abstract. Finally, it will give you this judgment. Here he's telling me the study involves. This is why we choose this to to include the study. Okay, a study involves human patient with Alzheimer's disease and discusses the pharmacological treatment algorithm, specifically for behavioral and psychological symptoms related to Alzheimer's Alzheimer's dementia. It includes evaluation of multiple drugs and their efficacy, tolerability, and safety considerations, meeting the criteria for focus on Alzheimer's medication and pharmacological treatments. If he excludes something, he also will tell you why he excluded this. For example, this is a review article focused on potential of lipid-based nanoparticles as drug delivery vehicles for Alzheimer treatment rather than on specific pharmacological treatment, okay, etc., etc. You can still go, you can still do a second check by human eyes, by your eyes, as a researcher, and agree or disagree with the decision. Sometimes it will give you here, instead of exclude or include, it will give you maybe. So you need to solve this conflict by making a final decision, include or exclude. Finally, the final decision is the researcher's decision. If you agree with the AI's decision, then keep it. If you disagree, change it. Okay. Also, I will tell you this. I don't know you meant it or not, but why for the hypothesis synthesis pipeline I am using only abstracts to synthesize hypothesis and to screen or to make my causal pathways and this entire pipeline. For two things, I think, or more. First thing, I don't want to spend much time on reading full text articles. I need full text articles. Researchers usually include the most important finding of their paper into the abstract, and I want only the most important and final findings of the paper in one or two words. Okay, the abstracts will contain this. This is good, and this also will save time. Second thing, also I don't want to upload the full text and full text PDFs to the system one by one. For example, for 1,000 paper. Okay, it will be huge. It will take forever, and also it will make the system take forever to finalize all of the extraction, and it will generate a lot of redundant and unnecessary data for this purpose. But in case of you are using the meta-analysis pipeline, this is coming soon. The exact pipeline and the exact steps for literature screening and so on. But in the meta-analysis pipeline, you are going to have finally 10 papers, 5 papers, 20 papers, 50 papers at most to include in your research paper. Okay, so you will be able to do this, and it will not be a problem for you. So this is my reasons for the current configuration of the pipeline. Does this answer your question?
I got the majority of the point. Also, there's a simple point additional, that how to import. For example, when you're doing search strategy to extract articles, you are doing on PubMed, Cochrane, and others. So you have 100 here, 100 here, and so on. For example, just how to import them. Just the link of PubMed or what?
Oh, okay. This is a PubMed. Okay, this is PubMed search engine. Same PubMed engine. You can run your search in here, and you can run it on PubMed. It will be the same results because this is the same engine, same database. If you are interested in using other databases other than PubMed, I make a CSV format including these items in items as naming of the columns, and add your data and upload it to it. Whatever if you want to import from Scopus, import from Web of Science, Ovid, Cochrane, anywhere. Okay. Also, PubMed is good. PubMed includes high quality peer-reviewed paper, and if you are doing or you are using hypothesis synthesis pipeline, I recommend you to stay with the default in here. Use PubMed because you are finally doing a representative. You are taking a representative sample of literature, even if it's not the all literature. You are going to make a representative sample size of literature that if you make conclusion from it, because it is big enough to generalize, and your conclusions can be comprehensive. Okay, so feel free. Feel safe to use only PubMed as configured in this system. Otherwise, if you are interested in specific topic or you have different research question, I don't know, maybe you are interested in something different, so upload your abstracts and everything using this functionality. Finally, okay, Dr. Hussam, have I answered your question?
Yes, I got it. Great work.
Okay, now this is the integrated pathway. This is the integrated final pathway. Now we have pathogenesis and the microglial dysfunction, nanotechnology and the drug delivery strategies, therapeutic molecular action, and the microglial polarization and neuroinflammation, and clinical and behavioral outcomes. As you can see, it's not comprehensive. It's not capturing everything about Alzheimer's disease because we have only included 4 papers, and we have only very few extracted entities, and definitely 4 articles doesn't capture everything about Alzheimer's. We need to include at least a few hundred papers to be able to make such decisions. And finally, you will have your library, a nice library of clusters. Here is the cluster, and this is the cluster summary, and also this is a graphical summary of the cluster, and this is also a graphical summary for the second cluster, and this is this is what is going on, the description of everything inside this cluster. Now I have concluded everything about the application. The last only thing that I want to show you is the scientific illustrator. Scientific illustrator, we are intending to use this as a professional scientific illustration and graphical representation, because you see in here, this is very good, very good graphs, and we are using the same system for graphics, for graphic generation. And in here, you have Sci Illustrator editor. You can upload whatever image or things that you want to do editing on it. It will and describe exactly what you want to do, and it will do it for you. This part is an interactive scientific or interactive illustration editor. It is under testing right now. Also, we are intending to add more features like real-time editing instead of only using this chat box. I'm not fully satisfied with this chat box, but it is good enough for now. Later, our team is going to include more features. And for the Sci Illustrator Planner, you add in here. You can add using the visualization prompt, the default one. And after it, you add your manuscript, whatever the manuscript you want to add. For example, let's go to maybe uh, where to go. Okay, let's open any abstract from here. Graph, render, click on this, and let's open this. Uh, and let's copy first the abstract. I will copy all the abstract, and I will tell the model, okay, I want a graphical conference, like graphical representation of this this abstract, and generate plan. It will take few seconds. Okay, first you paste your abstract or methods or pathway or everything or anything you want, even the entire manuscript, and create a plan. After that, you will have an option here to use in the image generator, and your work is going to be automatically saved. Uh, okay, use an image generator, create image, generate publication quality, everything. Uh, Literally, the only limitation in this tool for scientific illustrations, is your imagination. You can do whatever you want and very simple, as you can see, very simple to deal with, very straightforward. The system do everything for you, and gives you uh, high quality outputs. And as you can see, everything in here is first shot. Okay, you just click and you don't repeat anything in here. You get the final result from the first shot, and results are really reproducible. You will have the same result every time you run your pipeline. Okay, now let's read the paper. Is customized intranasal hydrogel delivering methylene blue, ameliorates cognitive dysfunction against Alzheimer. Okay, and this is intranasal administration and hydrogel. Look at this. This is the hydrogel going to the epithelial mucosal cells, and this is what is going on the molecular level, at cellular and molecular level. Brain delivery and the blood-brain barrier bypass. It will do these things. This is the blood-brain barrier, and this is the targeted brain delivery and molecular mechanism inside neurons. And neuroinflammation. Finally, you can download, and we have finished our illustration. And this concludes our demo for the application. Now I will stop recording and I will receive your questions.